Good morning students. Now HS2ndyr CMST class and we are doing binomial expansion. So binomial theorem, binomial expansion we are going to do as we are continuing, and formula we are following it is a plus b whole thing to the power n. It is nc0, you can write for your convenience, nc1 a to the power n minus 1b nc2 a to the power n minus 2 into b square. In this way, last term is ncn b to the power n. When minus, alternatively plus minus these things. So we have done last in exercise 2.4. In exercise 2.4 we have done question number 2.1. Another thing we have done that day is Pascal's triangles also, that we will do again. So now question number 2 x minus 1 by x to the power 6. Pascal's triangles we again want to do 1 3 3 1 1 3 4. This to 6, this is 4 1, this 2 gives 5, this is 10, this is 10, this is 5, this is 1 1 6 15 20 15 6 1. Now if we follow this formula according to that, if we write, then of course I want to write this one as 6c0 x to the power 6, then minus, alternative plus minus will come 6c1 x to the power 5 1 by x, 6c2 x to the power 4 1 by x square, minus 6c3 x to the power 3 1 by x cube, plus 6c4 x square 1 by x to the power 4 minus 6c5 x 1 by x to the power 5, and finally 6c6 1 by x to the power 6. Now Pascal's triangles will help us from what? 6c0 is 1, 6c1 is our 6, this is 15, this is 20, this is 15. In this way we can get from this one. Okay, so 1, then x to the power 6. You can break it combinations also. NCR formula, factorial n divided by r, factorial r into factorial n minus r. That formula also you can use, or you can use this one. Whichever is convenient, you can use this one. Minus this one already we have done, it is 6. This will cancel, x to the power 4 will come. This will give 15. And these two cancel and it is x square. This, it will be 6 is this 4 is, sorry, this one is our, it is 20 according to this one, and after cancelling it is the 1 only, no x term is there. This is the term where it is 15, and if we cancel it is 1 by x square. This is 6 and it is 1 by 4, and this is the 1 by x to the power 6. So this is the answer of this question. This is expansion of this one. So we can do by this way. So there are 3 other questions. So I will show 3rd and 4th is your homework. I will show only the question number 5. So how to do question number 5, we'll see. Yes, 5 is a little bit complicated. 2, 5. 3 and 4 is similar, that's why I am not doing. Here, x square plus x plus 1 to the power 4. You consider this as single term, this as, so shall I write like that? This is our a, this is our b. 4 power, so this value will take. So we can write 4c0 x square to the power 4 plus, then according to this 4c1 x square to the power 3 and x plus 1. Then 4c2 x square, power is will be 2 and x plus 1 whole thing square plus 4c3 x square power will be 1 and this will increase, x plus 1 power will be 3. Finally 4c4 and it is x plus 1 to the power 4. So this is our total expansion. 4c0 according to this one, it will be 1, 4c1 4, 4c2 6, 4c3 4 and this one is 1. So it will be 1 only and this to multiply it will give 8. This one is 4. Then x to the power 6 inside bracket x plus 1. This one is 6 x to the power 4 and this if we break a plus b whole thing square formula x square plus 2y6 plus 1. 4c3 is again 4 x square and this value if we break x cube plus 3x square plus 3x plus 1 a plus b whole thing cube formula. 4c4 is 1, this one, yes, according to this value we can write and we get that value as x to the power 4, then 4x cube, 6x square, 4x plus 1. So this is our total term. Now we have to merge all these things. X to the power 8 is our final. These two if we multiply, then of course this will give as value of x to the power 7. 4x to the power 7 will come. And you will find in no places 4 to the power 7. So we can write 4x to the power 7. If we multiply 4x to the power 6 into 1, 4x to the power 6 and these two if we multiply 6x to the power 6. So 4 plus 6 it is 10 and just no x to the 10 x to the power 6 we will get. So this one finished, that one up to finished. Now x to the power 5, this if we multiply it is 8x to the power 5, 8, this two will give, it is not 8, it is 12x to the power 5 and here it is 4x to the power 5. So it is 16x to the power 5. Now x to the power 4. If we multiply this into 1, it will be 6. These two if we multiply, it is 12. And this one is 1. So it is 18, 19x to the power 4 plus. Now x cube. If we multiply this and that, then this will give 12. 12x cube, 12 plus 4, 16x cube. Then 4 and 6, 10x square. Then 4x plus 1. So this is our total expansion of these values. So with that we end our question number 2 of this exercise. Now question number 3, that is using binomial theorem, find the values of 1.03. So now we are going to do question number 3. They said you have to find the value of 1.03 to the power 4 and of course you have to use that formula and they say correct decimal up to 4 places you have to put. So if I write this one as 1 plus 0.03 to the power 4, then if we break 4c01 to the power 4, 4c1 1 to the power 3 into 0.03, 4c2 1 square, 0.03 square, then 4c3 1, 0.03 cube, plus 4C4 0.03 to the power 4. So see, this I have done. 4C0 is our 1. 1 into 1 to the power 4, that is 1 is 1. 4C1 is 4. This is 1, this is 0.03. 4C2 is our 6. This is 1, and this if we square it will do, it is 0.009. I think if you multiply automatically 3 3s are 9 and 4 digit it will be. 4C3 is 4. This one, this is here, it will be 6 digit will be there. So 27, 3 cube is 27, 1, 2, 3, 4, 5, 6. This is 1, and if we multiply, this is 81, and it is 8 digit will come. 1, 2, 3, 4, 5, 6, 7, 8. So up to this one. Now if we multiply 0.12, then 0.0054, 0.108, so another 1, 2, 3, and 0.0000081. Now if we add 1.12, then you see it is from third digit, so no other term in the third digit. 4 will add with this one, 4 plus 1, 5. Then 0, it is our what, fifth word, 1, 2, 3, 4, 5. So it is the 4 will come, so 4 is on 1, 2, 5 here 4. This 0 is no other 0, so it is 0. Then 8 is with this one, so 8, 1. So total value is this, but they said up to what, 4 decimal. So up to this one they have said to take. So this is our answer. So students, how to use the binomial theorem, that is our, they have said this one, that you use the binomial, find the values. Simply note the multiplication we have used, and then we have find this one. So that is the use of binomial theorem. I expect you have learned that one, and try to understand these things. So use of binomial theorem, especially so many persons will say so many formulae you have to learn. I will say that only you learn this one, that is sufficient, not to do this. So many formulae for binomial theorem, only one is sufficient. And with one only I have used, only minus when it is, then plus minus alternative is there. Other cases it is same. So student, that much for today. Give your attendance in your comment box.